Now in our chemistry course, we're going to start to look at chemical reactions. Here what we have is what we call a chemical equation. It's where we write the reaction out using chemical symbols. Now, we looked at these in grade 9. You'll remember some terminology that will help us here today. We call anything that we start with a reactant, and anything that is produced by the chemical reactant a product. So anything that's produced by the chemical reaction is a product, it's a reactant. Now the arrow in between, what does that mean again, or how do I read that? Because I don't say H2O, arrow, H2 plus O2. I'm going to read that as reacts to produce. Now we could also use a word equation, and that's where instead of using chemical symbols, we would write this out using words. So it would be water, still using an arrow then, hydrogen gas, and oxygen gas. I'm just writing that out. Obviously a chemical equation is just a little bit preferred because now we can see exactly what's going on, which atoms are involved, which elements, and how many of each element. Now if we look a little closer at the same chemical reaction here, we'll notice that something isn't quite right. And it's not that water doesn't decompose under the right circumstances into hydrogen gas and oxygen gas. That in fact does happen. Well, the issue is, if I look very closely at my reactants, I have 2 hydrogens and I have 1 oxygen. In my products, I have 2 hydrogens and 2 oxygens. So it would appear that somehow, magically, we've just made an oxygen appear, because there's only 1 here and there are 2 here. And that really does not happen. We can't make things magically appear or magically disappear in another circumstance. And we can't get something, from nothing. So, what we call, this is still useful, this is what we call a skeletal chemical equation. And it really shows the bare bones of what's going on in a reaction. It's similar to how on a Coke can, it'll tell us all the ingredients, but if I take those ingredients, I'm not necessarily going to produce Coke. I need to know how much of it is involved in the recipe. And so that's what we're going to try to do. We're going to try to figure out the quantities involved with this. We've seen that it is impossible to get something out of nothing and to make something magically disappear in a chemical reaction. And this is all because of our results that we saw in our lab that told us really what the law of conservation of mass is all about. That's where we discovered it. And that, if you remember, the law of conservation of mass states that the mass of the reactants is equal to the mass of the products. So we never see any sort of change. And this leads us into what we're trying to do with these unbalanced skeletal equations. We are trying to balance them to show what really happens. In other words, to figure out the quantities of the molecules involved in both the reactants and the products. Let's take a look at how we solve these types of problems. Okay? So what do? Well, we need to go through and first do a little bit of accounting. We are going to go through and try to, we call, balance this chemical equation. And how we do that again is by doing some accounting. So what I'm going to do is I'm going to write down what is involved and what do we have in the reactant. So for each element involved, I'm going to go through and say, well, I've got hydrogen, I've got oxygen. And that's really all I have here. This is pretty simple. We'll get to more complicated ones. And I have 2 hydrogens and there's only 1 oxygen. Remember, if there's no number, that means there's a 1. And over in the products, as we've already sort of stated, I've got 2 hydrogen and I've got 2 oxygen. Now, what is going to make this right? Well, some people tend to want to do something like say, well, the problem's right here with the oxygens. And they'll say, let's just put a 2 right there. And then suddenly I'd have 2 oxygens, and then the sides would balance, which is what our goal is. However, unfortunately, H2O2, that's hydrogen peroxide. And that's changing what really was involved. We saw that water will break down into hydrogen gas and oxygen gas, not hydrogen peroxide. Okay? So that doesn't work. In fact, our rule is the only thing that you're allowed to do is to put a coefficient out in front of each molecule. So what I'm going to do is I'm going to put boxes around these, and I'm not going to change anything inside. The only thing I'm allowed to do is to go through and put a big box or number out front, or a coefficient. So I need 2 oxygens. So what number out front would give me 2 oxygens? Well, if I put a 2 out front, so the coefficient 2 would now mean that I have, in fact, 2 oxygens. However, that also changes things, and now instead I have 4 hydrogens, because there's 2 hydrogens in each molecule, and I have 2 molecules. So now it looks like we've created a bigger mess. Well, in fact, we haven't. We've moved closer to solving this chemical equation and getting it to balance. So what do I need to do over here? Well, probably many of you are saying, let's just put a 2 out front here, and suddenly now I'm going to have 4 hydrogen. 4 hydrogen over here, 4 hydrogen over here, 2 oxygen here, 2 oxygen here. So what we really discovered is that in order to make this reaction work the way we've written it before, we actually need 2 water molecules to be involved, and they're going to decompose into 2 hydrogen molecules and 2 oxygen gas molecules. And that's why in the electrolysis of water, we get twice as much hydrogen as we do oxygen. All right, let's try another example. Here we have in our reactants, we have methane and oxygen, and they're going to react to produce carbon dioxide and water. This is what happens anytime we light a Bunsen burner and we get it to burn, because that's really what we're burning, is we're burning methane gas in the presence of oxygen. Now, if we go through, and again, I would draw my line right down through the arrow so I separate my reactants from my products, and then I'm just going to go through and identify all of the elements involved. Okay? Now, every time I do this, I should get it so that the same elements are involved in the reactants as what I have in my products. If I don't have that, then there's no way that this is going to work, and I must have done something incorrectly. So let's go through and see how many of each we have. Again, this is where we're doing our little bit of accounting. So I've got 1 carbon here, 4 hydrogen, and 2 oxygen. In my products, 1 carbon, 2 hydrogen, and 3 oxygen. You'll see that we've got taken the 2 oxygen from here and the 1 oxygen there to give us 3. And that's okay that they can come from different spots. That may make things a little bit more difficult when we're trying to balance things. All right, so where are our problems? Well, we can see that we have 4 hydrogen here and 2 there. That's a bit of an issue. And we've got 2 oxygen here and 3 oxygen over there. So that's an issue. Now, this is a big tip. Anytime I have, let's do a little observation here. If I put a 2 out front here, I would end up with 4 oxygen. If instead I change this to a 3, I'd end up with 6. I put a 4 here, I have 8. In other words, no matter what I do, no matter what number I put there, I'm always going to get an even number of oxygens. So there's no way I can ever get something to be 3 oxygens on this side. So that's a problem. So a good strategy is to go through, and we're going to talk a little bit more about strategies tomorrow in class, is to always make it even over here when we see that we can never have an even number or an odd number on that side. So in order to make my oxygens even, what change should I make? Well, really I've got 2 here, so the issue is coming from the oxygen in the water. So what I'm going to do is I'm going to put a coefficient of 2 out front. Remember, the only thing I'm allowed to do is put big coefficients out front of the molecule. What's that going to change? Well, now I have 2 oxygen here and 1 oxygen in each molecule, but I have 2 molecules, so 4 total. That also changed something else. That changed my hydrogens. Now I have 4 hydrogens there, 2 in each molecule, and I have 2 molecules. So my only issue now on this side, because my carbons are the same, that's good, hydrogen's the same. The only issue is the oxygen. What do I need to do? Well, I need to put a 2 out front, and that will balance it up. The nice thing about these questions is that you'll always know that you've got them right. So you can continue to work at it until you've solved it. And therefore, usually students end up getting very, very, very high marks on these types of questions on quizzes and tests. And so they generally like them.